Today I am going to discuss the half wave rectifiers. Before going to half wave rectifier, first what is the rectifier? Here the rectifier means the rectifier which convert from AC voltage to DC voltage. All the rectifiers convert from AC voltage to DC voltage. So the application of rectifier means which electrical component require the DC voltages, we will provide the DC voltage with help of these rectifiers. So this rectifier will be convert that AC to DC with help of diode. Okay, see here what is the rectifier? A half wave rectifier. This rectifiers has two types. One is the half wave rectifier and full wave rectifiers. Again, this full wave rectifier classified into two categories. One is the center tap rectifier and second one is the bridge type rectifier. Okay, so first today now I will going to discuss the half wave rectifier. A half wave rectifier is defined as the type of rectifier that only allows one half cycle of an AC voltage waveform to pass, blocking the other half cycle. See here, the half wave rectifier, a rectifier means which convert from AC to DC. But in case of half wave rectifier, it will be convert only one half cycle of AC voltage waveform to pass. That is one which type of half cycle will be convert to DC voltage means the positive half cycle will be convert from AC voltage to DC voltage. Next, blocking other half cycle, the negative half cycle of the AC voltage will be blocking to the rectifier. So the half wave rectifier are used to convert AC voltage to DC voltage and only require a single diode to construct. This half wave rectifier it has the only single diode, one resistive load and transformer also, step up transformer or step down transformer. Why the transformer will be used here? Because with help of this transformer we will be convert the high voltage to low voltage or low voltage to high voltage. Which amount of which required voltage we want, that amount of voltage will be convert from step up transformer. So that's why we are using step up or step down transformer in rectifier circuit. Next, a rectifier is a device that converts alternating current to direct current. It is done by using a diode or group of diodes. See here, this rectifier will be converting from AC current to DC current by using a diode or group of diode, because in half wave rectifier we are using only single diode. In bridge type rectifier or center tap rectifier, there are different types of rectifiers there. This full wave rectifiers has two types. One is the center tap rectifier and second one is the bridge type rectifier. In case of center tap rectifier, we are using two diodes, and in case of bridge type rectifier, we are using four diodes. In case of bridge type rectifiers. Okay, so in this way, while a full wave rectifier use the multiple in the here, it is done by using diode or group of diodes. Half wave rectifier use one diode, while a full wave rectifier uses multiple diodes. The working of a half wave rectifier takes advantage of the fact that the diodes only allow the current to flow in one direction. The standard function of diode is the diodes allow the flow of current in only one direction through it. See here. So the diagram below illustrates the basic principle of half wave rectifier. See how the waveform half wave rectifier will be converted from AC to DC voltage will be explained with help of this diagram. When a standard AC waveform is passed through a half wave rectifier, when a standard AC voltage will be passing through a half wave rectifier, that means we are giving the AC voltage as a input to the rectifier. Okay, which rectifier we are using to convert from AC voltage to DC voltage, we are giving the AC voltage as the input. That's why only half the AC waveform. See here, when a standard AC waveform is passed through a half wave rectifier, only half of the AC waveform remains. Half wave rectifiers only allow one half cycle, that is positive or negative half cycle of the AC voltage through, and will block other half cycle on DC side. Okay, it will be allow only one half cycle. In which type of half cycle will be allowed to pass the current through diode means, so which diode in a forward bias condition, in which half cycle, either positive half cycle or negative half cycle, in which half cycle the diode will be act as a forward bias condition, in that half cycle will be convert AC to DC, and which half cycle the diode will be act as a reverse bias, that half cycle will be block the PN junction diode, because the diode only allowing in only one direction, that is when the diode will be act as a forward bias condition. On that condition the diode will be allow the flow of current through it, and when the diode will be in reverse bias condition, on that condition the which half cycle will be connected to reverse bias condition, the diode doesn't allow the flow of electric current. See here when the standard AC voltage will be given as a input voltage, see here, this is the standard AC voltage is given to the input to the PN junction diode. In rectifiers we are using mostly PN junction diodes only. See here, this is the AC voltage, this is the PN junction diode, means this PN junction diode means this the rectifier circuit has PN junction diode. With help of this diode it will be convert to AC to DC, that is called rectifier. So this is the PN junction diode, and this is the pulsating DC current. Actually rectifier means which convert from AC to DC, but exactly the rectifier convert from AC to pulsating DC. It doesn't convert pure DC. The rectifier always converts from AC to pulsating DC current. See here, in positive half cycle this diode will be forward bias condition. In positive half cycle this diode will be forward bias condition, and it will be allow the flow of current. See this is a diagram. See this is the output and this is the input. So observe the output side. In output side the positive half cycle is converted to DC and negative half cycle is blocked here. Because why this will be happen, because in positive half cycle the diode will be forward bias. Next in negative half cycle the diode will be reverse bias. The diode always allow the current in forward bias only. So in negative half cycle it will be reverse bias, that's why it doesn't allow the flow of electric in negative half cycle. Again positive half cycle it will be conducting, again negative half cycle it will be not conducting, again positive half cycle it will be conducting. Like this the half wave rectifier will be work. See here the complete set of half wave rectifier. A complete half wave rectifier circuit consists of three main parts. One is the transformer, and second is the resistive load, and third is the diode. Transformer, resistive load and diode. So what is the function of transformer means, with help of this transformer we will be convert the voltage, we will be step up or step down to the voltage to be required, the voltage, how much amount of voltage will be required to convert from AC to DC, that amount of voltage will be converted from higher to lower or lower to higher with help of transformer. Here we will be use step down transformer. So yeah, that is the transform function. Diode, here the diode is the key role play in rectifier circuits. These diodes allow only flow of current in DC is one direction only. Next to resistive load, one resistive load is connected to the PN junction diode to form the electric current. This is the voltage source. See here how it will be working. First a high AC voltage is applied to the primary side of the step down transformer. See here this is the step down transformer, and input side is the primary side, and output side load is connected to the secondary side. Resistive load and diode is connected in resistive side, and the primary side of the transformer is connected to the AC voltage. That means we are connecting some AC, we are giving input voltage to the primary side. That step down transformer step down some amount of voltage. First a high AC voltage is applied to the primary side of the step down transformer, primary side of the step down transformer, and we will get a low voltage at the secondary winding which will be applied to the diode. See here the primary side we will be giving the high AC voltage applied to the primary side of the step down transformer, and result we will get a low voltage at the secondary winding which will be applied to the diode. The transformer output will be connected to input as a diode. Okay, after that during the positive half cycle, see here one diode will be connected here, and the diode will be connected anode and cathode. During positive half cycle of AC voltage the diode will be forward biased, and the current flow through the diode. See, all of you observe here, during the positive half cycle only the AC voltage, during the positive cycle of the AC voltage, say all of you observe in the diagram, during the positive half cycle of the AC voltage the diode will be forward biased. When the positive half cycle will be present in the AC voltage, on that condition the diode will be act as a forward biased and the current flow through the diode. So the current will be flowing through diode in only forward bias condition only. So when the diode will be in forward bias condition means during positive half cycle the diode will be forward bias condition. During negative half cycle the diode will be reverse bias condition. See here, during the negative half cycle of the AC voltage, here clearly represented, positive symbol is represented by positive half cycle, the negative terminal will be represented by negative half cycle. During the negative half cycle of the AC voltage the diode will be reverse biased and the flow of current will be blocked. See here, during the negative half cycle of the AC voltage the diode will be reverse biased and the flow of current will be blocked. The final output voltage waveform on the secondary side DC is shown in figure 3. See here, in during positive side this is the total rectifier circuit, half wave rectifier circuit. So here only one diode will be connected, one transformer will be connected and one resistive load will be connected. During positive half cycle, that is positive and negative, during positive half cycle this diode will be act as a forward bias condition and this diode always allow the current in only forward bias condition only. During negative half cycle the terminal of the transformer or source voltage is negative and positive. When the terminal will be interchanged in negative half cycle the diode will be act as a reverse bias condition. So in a reverse bias condition diode doesn't allow any type of flow of electric current. Okay, see here, this is the input and this is the output side. This is the input voltage. In input voltage side positive half cycle is there, negative half cycle is there, positive half cycle there, repeatedly it will be happen. So but in output side only during the positive half cycle it will be the DC voltage will be available. In during the negative half cycle it will be blocked. Again positive half cycle it will be present, again negative half cycle it will be blocked. In this way the half wave rectifier will be convert the AC voltage to DC voltage in only positive half cycle. So always a half wave rectifier is defined as the type of rectifier that only allows one half cycle of AC voltage waveform to pass and blocking other half cycle. So when the positive half cycle present in the input voltage it will be the diode will be act as a forward bias condition and it will be allow the flow of current through it. And next during the negative half cycle, during the negative half cycle the diode will be act as a reverse bias and it blocking that negative half cycle. So the half wave rectifier are used to convert AC voltage to DC voltage and only require a single diode. With help of single diode this this half wave rectifier will be converted from AC to DC only. Okay, next and the efficiency of the half wave rectifier is 40.6. Why this efficiency is 40.6 means the half wave rectifier is converting only one half cycle. Only one half cycle is converting from AC to DC. The remaining half cycle will be blocked. That is this half wave rectifier using only 50% of the input and it will be convert that 50% of the input into 40.6% of the DC voltage. The remaining 9% or 10% of the voltage will be losses due to semiconductor materials and diodes losses. So the efficiency of the half wave rectifier is 40.6 only, and this half wave rectifier using only one diode. So the construction is very simple and the initial cost also very less because it has only one diode as compared to other rectifiers. The center tap rectifiers has two diodes. So two diodes means the construction will be difficult and maintenance also high, maintenance cost also high, and the construction cost also high in case of center tap rectifier, center tap full wave rectifier. And bridge type rectifier also has four diodes. It has four diodes means its initial cost is high, construction cost is high, construction is difficult, maintenance also high as compared to half wave rectifier and full wave rectifier. But the efficiency of the full wave rectifier is high because these full wave rectifiers will be convert both positive half cycle and negative half cycles also. So the full wave rectifier is 81.2 efficiency of the full wave rectifier. So the half wave rectifiers has only one diode, maintenance cost is less, initial cost also less, construction is simple, and but the efficiency also less, 40.6% only. Okay, this is the half wave rectifiers. Only this half wave rectifier during positive half cycle, it only the diode will be act as a forward bias and the current flow through the diode. During the negative half cycle of the AC voltage, the diode will be reverse biased and the flow of current will be blocked. The final output voltage waveform on the secondary side is shown in figure 3 like that. Only positive half cycle will be conducted and the negative half cycle will be blocked. Thank you.